Dear students, let us to continue the remaining part of scalars and vectors. So in previous class we have already discussed about the scalars and vectors. So today we have to discuss the multiplication of a scalar quantity with a vector quantity. Okay, that one is called as scalar multiplication. So multiplication of a vectors by real number, that is scalar multiplication. Okay, see, suppose a vector a is multiplied with a positive number lambda gives a vector for lambda times a, that is the magnitude is changed by the factor lambda, but the direction is the same as that of a. And one more thing you have to remember, if the lambda is negative, then the direction of the vector becomes opposite to that of vector a. See, for example, all of you know the relation force equal to mass into acceleration. Here force is vector quantity, mass is scalar quantity, and acceleration is vector quantity. Suppose the mass is 2 kg and acceleration is 3 meter per second square along x direction, then the force is same direction along x direction, and 2 times acceleration, F equal to ma means 2 times acceleration, that is 2 into 3 means 6 Newton you can say. So this 6 Newton is the force, and the direction of the force is same as that of the acceleration. Okay, so this is one example for multiplication of vector by real number. You can take another vector, for example momentum. Momentum is mass into velocity. Mass into velocity is momentum, and here the direction of the momentum is same as the direction of velocity. Direction of momentum is same as that of velocity, only the momentum is mass times velocity. Suppose the mass is 5 kg, then we can say momentum is 5 times velocity, so like that. So only here the magnitude is changing and the direction remains same if the scalar quantity or that real number is positive. Okay, and there is some possibilities, if that scalar quantity that may be negative also, at that time the after multiplying a scalar with a vector, so we are getting the vector now, so that magnitude is more, but the direction becomes opposite if it is negative. Okay, so now by knowing about this, we go to the next term, addition and subtraction of vectors by graphical method. Here it is very important to know clearly about how to add two vectors. Two vectors can be added with the help of graph. It is not possible to add directly. Suppose for example, I will give one simple example. There are two masses, one is 2 kg, another one is 3 kg. So the net mass becomes 5 kg. 2 kg plus 3 kg is 5 kg. Cleared? Because we can add directly if the quantities are scalar. And one more thing you have to remember here, two quantities can be added or subtracted only when both the quantities are of the same kind. Okay, for example, we can add mass with mass, time with time, speed with speed, velocity with velocity, okay, etc. Okay, so let us to discuss the addition of two vectors. See, suppose there are two quantities, both are displacement. One displacement is 5 meter, another displacement is 3 meter. Then the net displacement is maybe 8 or is not equal to 8 meter also, because displacement is a vector quantity. We can't say one displacement is 5 meter, another displacement is 3 meter, means the net displacement is 8 meter. It never be 8 meter. You will get 8 meter only when the displacement, first displacement and second displacements are along the same line in the same direction. Then only we can say the net displacement is 8 meter. Otherwise, we have to draw these two displacements along with directions, then we'll get the net displacement. Okay, see here there are two vectors. The first line, there are two vectors A and B. That first line gives the magnitude and the direction of the first vector A, and second line is the indicates the vector B along with the direction. This arrow indicates the direction. So now how to add these two vectors? See, the length of the line is proportional to the magnitude of the vector. For example, you are adding two displacements. One is 5 meter, another one is 3 meter. So you have to draw two lines. One line is for first displacement 5 meter, another line is for the second displacement. So first vector is 5 meter, and it is not possible to draw that 5 meter line. So you have to take proportional to that 5 meter. Say for example, for 5 meter, if you draw 5 centimeter, okay, or you can take 2.5 centimeter also, okay, it should be proportional to its value. So for 5 centimeter, you have to draw 5 centimeter line, and for 3 meter you have to draw 3 centimeter line, and the direction of the line is along the direction of the displacement. Okay, and how to add these two means, first you have to draw the first vector. So in second figure, that the line OP gives magnitude and direction of the first vector A. Along the same line or same direction, we have drawn the line OP. The length of OP is same as the vector A. So then we can say the vector OP is same as vector A. Now one more vector B. So that vector B, you have to start at P and draw the same line, means same length of the vector B along with direction. So for first vector, O is the initial point, P is the terminal point or end point, you can say. And for second vector B, you have to start from B and it will ends at Q. So now we can say the line OP with arrow indicates the vector A, line PQ which indicates the vector B. Now the sum of these two means for first vector initial point is O, for second vector the terminal point is Q. So you have to draw one more line from O to Q, and the line OQ measures the sum of these two vectors. That is, we can say the vector OQ as R, and it's called as resultant vector, and this resultant vector is the sum of these two vectors. So that is vector OP plus vector PQ equal to vector OQ, that is R equal to vector A plus vector B. So this is the way of addition of two vectors. Is it clear? Okay. Go for next example. See, in this figure, vector A plus vector B is shown in the first figure, that is B, and in the next figure, here the first vector is QS, second vector is SP, then their sum is QP. So now we can write as vector B plus vector A equal to vector R. So both are same only. Okay. And see one more figure. Here there are three vectors A, B, C. The first vector A is shown in the figure with arrow, and second vector that will starts with the terminal point of A, that is vector B, and third vector is C. See, in this the initial point of vector A and the terminal point of vector B, you have to join with the help of one line. So that line gives the sum of these two, that is A plus B. If you join the initial point of vector B and the terminal point of vector C, then that gives vector B plus vector C. One more line is there, that is you have to join the line whose initial point is the initial point of vector A and the terminal point of vector C. So you have to draw one line, and that line indicates vector A plus vector B plus vector C, sum of these three vectors. Is it clear? Okay. So this is the way of addition of two vectors by graphical method. And one more thing you have to remember, the subtraction is same as the subtraction of two vectors is same as addition, only the difference is you have to add negative vector. By adding the negative vector is subtraction. Okay. So now there is one important law that helps for addition of two vectors. That law is triangle law of addition of two vectors. See, if two vectors of the same kind are represented in magnitude and direction, by two sides of a triangle taken in order, then their result is represented in magnitude and direction by the third side of the triangle taken in reverse order. See here, for a triangle ABC, suppose AB is taken as the first vector, BC is taken as the second vector. So you have to take the third vector, that is AC. Just we have already discussed the way of adding two vectors by graphical method. Here also the same. If you represent two vectors as the two sides of a triangle, then third side gives magnitude and direction of the resultant taken in reverse order. So this is the statement of triangle law of addition of two vectors. Okay, so the remaining part of this we can discuss in the next class. Okay, so try to write all the notes in a separate book. Okay, we'll check it later. Okay, thank you.